Hi everyone, today we're looking at Unit 5, Lesson 8, Mixed Word Problems. So we're going to start bringing together all the different kind of strategies we learned for solving quadratics, remembering that when we're solving our quadratics, we're generally trying to find one of those key points, whether that's the zeros, the vertex, or some value when x or y are given. So let's start with our first example. It says the height, h meters, of a batted baseball as a function of time, t in seconds, since the ball was hit, can be modeled by the function that you see there. So h equals negative 2t squared plus 10t plus 1. So we have a few questions to answer here. It says, what was the maximum height of the ball? B is asking, when did the ball reach its maximum? So whenever we see maximum or minimum, we should be thinking about finding the vertex. Well, if we're finding the vertex, we're in standard form right now. We need to get to vertex form. So we're going to do that by completing the square. Okay, let's take a look at A and B, and then we'll come back to C. So I'm going to rewrite our equation down here just so we can, again, point out what is usually my x value and what is usually my y value. So h equals negative 2t squared plus 10t plus 1. Okay, so height is usually where my y is, and time is usually where my x is. So we'll just keep that in mind as we solve these things. What's gonna represent the maximum height and what's gonna represent the time at that maximum height. So we'll start by completing our square. So to complete our square, we need to factor out that negative 2 just from my first two terms. So we'll have t squared minus 5t inside that bracket. Okay, from there, we're going to have to take our second term, and we're going to have half and square it. So we're going to take 5 divided by 2 and square it. So that's going to equal 6.25. So we're going to add and subtract that inside of our brackets. Then we need to bring the negative version of that out. So we have to bring that minus 6.25 out. Remembering when we bring it out, we need to multiply it by that common factor out front of our brackets. So we're going to have a negative 2 times that negative 6.25. Okay, and then we can just factor this perfect square trinomial. So take the square root of t squared and the square root of 6.25. So the square root of t squared is t. The square root of 6.25 is 2.5. And then we bring down the sign from our middle term to go between those. And we square that bracket. Okay, if we combine everything on the outside, we have a negative 2 times a negative 6.25. So that's going to be a positive 12.5 plus 1 would be a positive 13.5. So we can see that we're going to have a vertex at 2.5, 13.5, okay? So remember, my x represents our time, and our y represents our height. So part A is saying what was the maximum height of the ball, so that's going to be the y part of my vertex. So therefore, the max height is 13.5 meters. And then for part B, it says, when did the ball reach its maximum height? Well, that's going to be at the time. So we can say the max height was reached at 2.5 seconds. So that takes care of our first few questions. Let's look at the next one. Part C says, how many seconds after it was hit did the ball hit the ground? So if we're trying to figure out when does the ball hit the ground, we should be thinking about finding our zeros, right? Because that is going to be when the height is at 0. So we're going to need to find our zeros. So for part C, we'll take a look at if we can factor if I plug in a 0 for my height, right, we're going to have a negative 2t squared plus 10t plus 1. We have to think about, can we factor this? So are there two numbers that are going to multiply to a negative 2 but add to a positive 10? No. There's nothing that's going to work for that. So we're going to use our quadratic formula. Okay, so in this case, we're trying to find t. So we're going to say t is equal to a negative b. Well, b is 10 in this case, plus or minus the square root of our b value squared minus 4 times my a, which is a negative 2, times c, which is positive 1. All of that is going to be over 2 times a. Okay, so we're going to simplify as much as we can. We're going to get a negative 10 plus or minus. And then under that square root sign, we should end up with 108. And that will be over a negative 4. So we'll break this into our two equations now. So we'll have t equals negative 10 plus, and the square root of 108 is going to be 10.4. All of that over negative 4. Or we're going to have that t equals negative 10 minus 10.4 over negative 4. So this will simplify to a negative 0.098, and this will simplify to 5.098. Okay, well, if we're thinking about time, we can go ahead and reject this one because we don't want to have negative time. Okay, so we can say that therefore it will hit the ground at, and we'll round it to just one decimal, 5.1 seconds. Okay, we have a few more questions to answer this one. So what was the height of the ball when it was hit? So remember, that's our initial value, also known as our y-intercept. And what was the height of the ball 1 second after it was hit? So this is asking us, what is our height equal when t equals 1? So we can easily sub that in. But let's start with d. So for part d, our y-intercept we can find right from our standard form. So c equals 1 in my standard form of my equation. So we can say the ball was hit 1 meter off the ground. Okay, and then our last question, question E, what was the height of the ball when t is 1? So we're going to sub in a 1 for our t. So we're going to have a negative 2 times 1 squared plus 10 times 1 plus 1. So 1 squared is 1 times negative 2 is negative 2 plus 10 plus 1. So a negative 2 plus 10 is going to be a positive 8 plus 1 is 9. So therefore, the ball is 9 meters high after 1 second. Okay, so really breaking down what key points or information are we trying to find based on the questions in the word problem. Let's look at a few more. Okay, it says a photograph measures 10 centimeters by 6 centimeters to be surrounded by a mat before framing. The width of the mat is to be the same on all sides of the photograph. The area of the mat is equal to the area of the photograph. Find the width of the mat. So just like in our previous day's note, we're gonna try to draw a picture in this case. And we talked about this idea of a uniformed width. So let's first draw a picture of what's going on here. So we have a photograph. So we'll have our photo here. And it says the photo is going to be 6 centimeters by 10 centimeters. So we'll label this 6 centimeters and this 10 centimeters. It says it's surrounded by a mat before framing, and it says the width of the mat is to be the same. So that's that idea of that uniform width all the way around. So we'll try to draw it so it looks like it's about the same width all the way around my frame, all the way around my photo. Okay, it might look a little not exactly perfect to scale, but let's let W represent the width of the mat. Okay, so we can say that this is W from here to here, from here to here is W, okay, from here to here is W, from here to here. All of that is going to be represented by a W. Okay, we have the area of the mat is equal to the area of the photograph. Okay, so we're going to have to use area at some point. So let's remember that area equals length times width. Okay, the area of our photograph, if we're just talking about the area of our photograph, that's going to equal, and I'm just going to write a little subscript here, area of photo, right, not the whole thing, is going to equal 10 times 6. So that means it's going to equal 60 centimeters squared. Okay, so my total area, right, my total area is going to be twice that, because we know the area of the mat is going to be the same as the area of the photo. So the area of the mat is also 60 centimeters squared. So we could say total area is going to equal 120 centimeters squared. So let's see if we can set up an equation to represent our total area in this case. Okay, we know that the area itself is going to be 120 centimeters. That's going to be equal to my length and my width. Well, if I look over here and I try to determine, okay, what's my width of the entire thing? Okay, I know I have a 6, but then I have a W and a W that also makes up that width of the photo. So I would say this is 6 plus 2W. And if I wanted to represent this side of my photograph, right, I know I have 10, but then I also have these W's. So this is going to be 10 plus 2W on this side. So our area is going to be represented by multiplying those two together. So we'll have 6 plus 2W times 10 plus 2W. Okay, and now we'll work to expand and simplify, because when we're trying to solve a quadratic, we know that the solutions are x-intercepts or our roots. Okay, so I'm going to start by foiling. So we'll have 60, and then my outside terms is 12W, inside is 20W, and my last term is 4W squared. I'm just going to do some rearranging, so I'll bring my 120 over while I do that. So I'll have 4W squared. I'll combine my 12W and 20W for 32W. And then I'll have 60, and I'm bringing over that 120 by subtracting it, so we'll have a negative 60 there. Okay, we need to try to solve for W. So if we're solving for W, we have to find our solutions. Okay, so when we're looking, we have to think about how can we factor this. So if we're going to factor this, let's start by common factoring. I can common factor out a 4, and I'll be left with plus 8W minus 15. Okay, and then we'll set up our SPF. Is there something we can factor this using trinomial factoring? So it needs to add to a positive 8, but multiply to a negative 15. 5 and 3 sound like they might work, but if it needs to multiply to a negative but add to a positive, then there's no combination of 5 and 3 that's going to work. So we're going to need to use the quadratic formula. So I'm just going to box this little area off so we can use our quadratic formula. Okay, so if I set up my quadratic formula, that means in this case W is going to equal, and then we're going to have a negative B, which is 8, plus or minus the square root of B squared minus 4 times my A value, which is 1, times my C value, which is negative 15. All of that is going to be over 2A, so 2 times 1. So W is going to equal negative 8 plus or minus, under that bracket we should get, or under that square we should get 124 divided by 2. So if we split that, so we have W equals negative 8 plus the square root of 124 is 11.1 divided by 2, or we'll have W equals negative 8 minus 11.1 over 2. Okay, so the positive version, we're going to have W equals 1.57, and the negative version over here, we're going to have W equals a negative 9.57. So again, we don't want the width to be negative, so we can reject this value. And we've found our W, so we can say, therefore, the width is 1.57 centimeters. Okay, if we needed to find our length as well, we could plug back into those binomials up here that we had to find the length and width of the total picture frame, but they're just looking for the width of the mat. Okay, so we found that by solving for W. Okay, we'll try one more problem. Okay, last word problem we're going to look at for this note. A theater seats 2,000 people and charges $10 for a ticket. At this price, all tickets can be sold. A survey indicates that if the ticket price is increased, so we're looking at maybe representing a variable that will represent an increase in price, the number of tickets sold will decrease by 100 for every $1 of increase. What ticket price would result in the greatest revenue? Okay, so we have a couple things here. We have greatest revenue. When we think of greatest, we should start thinking about what does that mean. But if we're talking about price increases, let's let X represent the number of number of $1 price increases, because they said they're going to make increases in increments of $1. Okay, when we see greatest revenue, we should be thinking we're going to find our maximum, which means we're going to need to find our vertex, which means we probably need to complete the square. Okay, so let's try to set up an equation that represents this. Remember that if we're trying to find our greatest revenue, well, revenue equals whatever our price is times the number, in this case, of tickets sold. So you have to think about how can we represent price. Well, right now we know price is $10, but they're going to have some type of price increase that is going to be representative in $1 increments. So we can say it's going to be plus 1 times some number of price increases. We don't know what that's going to be yet. And our number of tickets sold, we know for sure they're going to sell 2,000 tickets at least. But from that, they have to decrease 100 for every $1 increase. So they're going to subtract from that 100 times however many price increases they're going to have. So minus 100x. So this represents our increase in price and this part here represents the decrease in the number of tickets sold. So our decrease in tickets sold, okay? Because as we change our price, that's what's going to happen. Price part's going to go up, but the number of tickets part is going to go down, which makes sense if you think about it. As price goes up, less people are going to buy. So we're going to go ahead and FOIL this. So when we FOIL it, we should get 20,000 minus 1,000x plus 2,000x and then minus 100x squared. I'm going to rearrange it so it's in our traditional standard form. So we'll have a negative 100x squared, and then negative 1,000 plus 2,000 is going to be a positive 1,000x, and then plus 20,000. Okay, so we're gonna work to complete the square, as we said, from here, because we're trying to identify what is our maximum revenue gonna be, okay? So if we complete the square, we need to factor out that negative 100 from the first two terms. So we'll have a negative 100 and then inner brackets x squared. Well, a positive 1,000 divided by a negative 100 is gonna be a negative 10x. And then we're gonna leave some space in our bracket for whatever we're gonna add and subtract when we complete the square. So if we're completing the square, we have to take that b term and we have to cut it in half and then square it. Okay, so 10 divided by 2 is 5. 5 squared is 25. So we'll add 25 and we'll subtract 25 inside of our bracket. Then we're going to pull that negative 25 outside of our bracket. When we pull it out, we have to remember to multiply by that common factor outside. So we're going to have a minus 100 times that negative 25 plus 20,000. Okay, so now we can factor our perfect squared trinomial we've created. We should get x minus 5 squared. And then if we combine everything on the outside there, a negative 100 times a negative 25 is going to be a positive 2,500 plus our 20,000. We're going to have positive 22,500. So if we were going to represent our vertex, we could say our vertex is at 5 and 22,500. Okay, so if we take a look at what x represents, this x represents our number of price increases. And our y represents our revenue. Okay, so it's saying what ticket price would result in the greatest revenue? Well, we're going to have 5 increases to price. Okay, so that means price is going to equal, my original ticket price was 10 plus the 5 increases. My ticket price is going to equal 15, squeezing it in there. So we can say, therefore, a ticket price of $15 will produce a max revenue of $22,500. Okay, so when you look at these word problems, we're really needing to identify what are they asking for. Are they looking for the vertex? Do I need to rearrange and solve to find my zeros? And if you're able to draw a picture, it will kind of help identify what's going on. Okay, that's it for your note for today.